Question number 6, we're going to write exponential function for 6 and an exponential regression equation for 7 that models the points on the table. So what I've done is I've put in the table, I've added a table, and then we are going to, we're going to write our equation. So the way that we ask Desmos to do an equation for us is we say y1 worm, and then the equation for an exponential function is ab to the x. So we're going to type in ab to the x power, but it's not doing something for us. It gives us an error message. We asked it to go look at our table for y1, so we need to add a 1 here to go look at your table for x1, and there you have it. Your a value is going to be 320, and your b value is 0.25, and then so you write to the x. You're going to do the same thing for the next one, and we can just change our table so that it says 0, 1, and that's a 3, and that's a 4. And then our values are 1,000, and then we have 610, and 220, and 132. And so then we go and look at our values here. Again, we have our a and our b. So we're going to write down y equals 1001.7 is our a value, times, and we're going to round this to the nearest hundredth. So we can say 0.61 to the x power. Question number 8. Mr. Green purchased a new combine for his farm. This is a combine. Over time, the combine will depreciate. So that means up or down. Depreciate is going to go down in value. What is the initial amount Mr. Green paid to purchase his farm equipment? So we have a graph. So it's talking about the initial amount. The beginning amount is right here, 120, but we need to read our labels. And this is not just $120, this is $120,000. So your answer is not C. It's going to be D. Be careful. What's your label? Why is the answer above not C? That's what we just talked about. Labeled $1,000. Make a table of values from the graph. So we have our x and y at 0. It was 120,000. At 1 year, it's going to be close to 100,000. So I'm going to use some more values that look exact. That one looks better. This one looks pretty good. This one looks pretty good. So I'm going to use those values because they look to be a little bit more precise. So 2, and if you want to estimate or guess, you can also use the other values. 2 is going to be 80,000. And then this one over here, 7, is going to be right at 30,000. And then over here, 9 is at 20,000. And again, you can use other values. You'll just have to say, well, this one's between 50 and 60. It's just a little bit above, not quite 55. So you would have to use your best guess, best estimation, and try to be a little bit precise. What is the domain of the graph? On the front, our domain was all real numbers because there was not a real life situation. When we're dealing with a real life situation, we are going to use the numbers in quadrant 1. So how low is this graph going to go? It's going to go all the way down close as it can get to this x-axis 0 here. This arrow shows that it's going to keep going. So we're going to say that our values are going to be between, for domain, we're looking at our x-axis that's going left and right. So we're going to use 0 is as far as it goes this way. And then this way it's going to keep going. There's no end on it. So we're just going to say that x is greater than or equal to 0. And this one can be equal to 0 because we are starting out at that $120,000 mark. What is the range of the graph? So again, this one's going to be y. We're going to talk about low to high. That's your y-axis. So the lowest value that we're going to get can go all the way down to 0. And then we're going to have greater than, and then we have our y, and then it's going to be greater than or equal to all the way up here at 120. And we're not going to make it equal to 0 because the graph is not actually going to touch. It's not going to go down to that 0 line.